The girls were having a lovely time frolicking and playing in the snow. They spent the afternoon enjoying hot chocolate, sledding, and making snowmen. Every year, they had a huge snowball fight, and this year, Hannah was not gonna come unprepared. So she set off on her own to make this year the best.
Looks like you need to make a box. A box? Yeah, to hold all of your snowballs. How do I do that? I'll show you now. First, we draw our box. Dimensions of 12 feet and 14 feet. Then we cut our corners, which would be the dimensions of x. The dimensions of each side would be 12 minus 2x and 14 minus 2x. Then we have our volume equation, length times width times height. Then we plug in each of the sides into this equation. Next we foil. Then we take the derivative. A 4 could be taken out of this equation to make it easier to solve. Because we cannot factor this equation, we have to do the quadratic formula. Plug in all of the elements into the equation. This gives us 26 plus or minus square root of 172 over 6. X would equal 6.5 or 2.14. Because 6.5 is not in our range, 2.14 would be the better choice. Then we plug in 1 into our derivative equation, and we get positive number 120, and we plug in 3 into the derivative equation, we get negative 660. This would give us 2.14 as our maximum. Now our new dimensions would be 9.72 feet by 7.72 feet by 2.14 feet.
Wow, thank you.
You're welcome.
Perfect. Now I'm ready for the fight.
Good luck.
After the fight, Hannah keeps one snowball with a diameter of 12 centimeters as a souvenir for her victory. If the rate that the snowball melts is 0.9 centimeters cubed per minute, at what rate is the radius changing?
First we draw our snowball with a diameter of 12 centimeters. Next we draw our equation. Volume equals 4/3 pi r cubed. Now we take the derivative. dv dt equals 4 pi r squared dr dt. Now we write our variables. R equals 6, dv dt equals 0.9. So in this case, we'll be solving for dr dt. After plugging in the variables into the derivative equation, we get 0.9 equals 4 pi 6 squared dr dt. Next, we divide by 4 pi 6 squared on both sides. This gives us dr dt, which is 0.001989 centimeters per minute.